Welcome to this explainer on industrial energy optimization. Look, if you manage a factory floor, you know that keeping operating costs down is basically a never-ending battle. Today, we're diving into the source material to break down a completely invisible leak in your industrial budget, and more importantly, the premium engineering upgrade that instantly seals it.
So here's the big question. How much energy is literally escaping from your machines right now? Think about it. If you walk past a massive plastic injection molding machine running at full tilt, you can feel that intense heat just radiating off the barrel, right? Well, those uninsulated exposed barrels are actively bleeding money straight into your ambient factory air.
And the data on this is actually wild. We're looking at a staggering 35%. Exposed high-heat machinery can result in up to a 35% total energy loss. Basically, every single time those heaters cycle on, up to a third of the electricity you're paying for never even makes it into your product. It just vanishes, poof, gone.
But you know, the true cost of these exposed ceramic heaters goes way beyond just a spiked electricity bill. As we can see in this breakdown, uninsulated machines actually force your climate control systems to work overtime just to fight those soaring ambient temperatures. And worse, because your heaters are constantly fighting that heat loss, you're looking at increased breakdowns and way shorter lifespans for critical components like your solid-state relays. Insulation completely flips this dynamic.
Okay, so what's the fix? Based on the source material, the definitive solution here is custom-engineered thermal insulation jackets. Specifically, we're looking at the iWrap and iHeat premium lines. And let's be clear, this is not some makeshift, messy fiberglass wrap. This is a highly technical, reusable engineering upgrade that's designed to look right at home in a clean, modern B2B facility.
These premium non-flammable jackets are built for a serious, industrial-grade fit. The heavy-duty stitching, the secure strapping mechanisms, the tailored cutouts for all your wiring and sensors, it's all meticulously engineered. They're designed to lock that thermal energy exactly where it belongs, while still being incredibly tough in extreme temperature environments.
When you actually see this in a real-world setting, it completely transforms the equipment. Just look at this clean, engineered fit on an active injection molding machine. That silver-gray thermal fabric gives it this super professional, secure finish. And more importantly, it completely eliminates those exposed, dangerous hot zones. So this one upgrade triggers a whole cascade of mechanical benefits. You're locking in up to 35% total energy savings and a massive 80% reduction in heat loss. This translates to much shorter heating times during startup, way less downtime for overworked components, and absolutely crucial, enhanced operator safety. No more risking severe burns on the factory floor.
But hey, let's move past the theory and dive into the hard, technical data. The sources give us a direct, before and after thermal analysis taken right there on the active factory floor.
Check this out. Before the installation, this machine barrel is a massive safety hazard, blazing at 158.5 degrees Celsius. But literally immediately after wrapping it, that surface temperature plummets to a completely safe 46.3 degrees. That is a drop of over 112 degrees. The machine is still running at maximum efficiency on the inside, but the outside is completely safe to touch.
So, what happens when we map that heat retention to actual power consumption? Well, the KWH study lays it out perfectly. A single injection molding machine saves roughly 21,672 kilowatts a year. To put that in perspective, that equates to over 1,95,000 rupees in pure annual savings. And remember, that's just for one single machine. Imagine multiplying that efficiency across your entire operation.
Projecting this out over a 3-year trajectory makes the financial impact absolutely undeniable. Year over year, the gap between an uninsulated setup and an insulated one just gets wider and wider. By year 3, the uninsulated machine has chewed through over 25 lakhs in electricity, while the insulated one sits at just under 20 lakhs. I mean, that becomes a massive competitive advantage for your business. Which naturally leads us to the ultimate metric for any decision maker, the return on investment. Compared to a baseline installation cost of around 60,000 rupees, those 3-year savings rocket past 5.8 lakhs. You're basically paying a tiny fraction up front to unlock this continuous flow of captured capital.
And because of these massive daily reductions in power, the complete ROI hits in an incredibly fast 3.2 months. Literally, before your first fiscal quarter is even over, the entire system has completely paid for itself. From month 4 onward, every single rupee saved is just pure profit added to your bottom line. There's a quote from the source material that just hits the nail on the head here. The more the heat is controlled, the more the profit increases. It's a really simple physical reality tied to a powerful financial truth. The tighter your grip on thermal loss, the higher your operational profit margins are going to climb.
So as we wrap up this explainer, it's clear that upgrading your equipment with premium insulation jackets isn't just about making the factory look good, or even just about safety. It is a foundational engineering upgrade that actually turns wasted heat into captured capital. So knowing the data, here is the final question you have to ask yourself. Can your facility actually afford the cost of doing nothing?